Welcome back to Filter Stories. I'm James Harper. And this episode here is part 2 of a conversation with my friend and fellow coffee podcaster, Lucia Solis. And it's an episode where I'm helping her get great water for coffee, a problem that so many of us coffee peeps have bashed our head against the wall trying to figure out. And the thing is, I have spent years researching this for my podcasts, and I have lots of answers. And so this is part 2 of this step-by-step guide for getting great water for coffee. In part 1, which I strongly recommend you listen to before you listen to this, I explained the 2 basic concepts for great water for coffee: alkalinity and total hardness. I had a great time doing it because I ruined Lucia's beautiful Kenyan coffee by increasing its alkalinity when we added baking soda. And I also showed her these really gnarly pictures of limescale buildup in espresso machine boilers. Now, part 2, this is where we get very practical. And I show Lucia how to measure her tap water for alkalinity and total hardness, and then lots of solutions she could follow to get great water for coffee. And my partner sponsor for these water episodes is PWT, the water filtration manufacturers. All right, let's jump back into the conversation. All right, Lucia, hopefully by now you are really familiar with the 2 key concepts when it comes to water for coffee: alkalinity and hardness.
So alkalinity is a thing that affects the way that we perceive acids. So when I had my coffee and it tasted completely flat, that was because my alkalinity was really high. And harder water impacts how much limescale my equipment's going to experience.
Exactly. And what you want is a little bit of each. A little bit of hardness, a little bit of alkalinity. So let's see, I have a question for you. What is the alkalinity and total hardness of your water?
James, if I knew that, I wouldn't have had to sit here and let you ruin my coffee and gross me out.
Ruin your own coffee.
But if I'm thinking about it, and if I had to get this number, and now what I know about alkalinity, I do have a pH meter in my kitchen, so I can go get my pH meter, and I also have a TDS meter. So if I get those 2 numbers, will that get me closer to knowing my alkalinity?
So I have bad news for you. The answer is no. But I think a lot of people in the coffee world are going to be in your situation, Lucia. They're going to have these instruments available, but they're just not going to help us. And I think it's worthwhile explaining why the most common tools coffee professionals already have in their kitchens: a pH meter, a TDS meter, like the one you have, which is a conductivity meter, and also a light refractometer. None of those things are actually going to help us know the alkalinity and total hardness of our tap water. So let's start with pH. And you mentioned you have a pH meter. So here, we don't care about pH. We care about alkalinity. Similar, but different concepts. And I think the best way to explain it to you is just like to imagine these 2 scenarios, okay? Imagine we had a glass of water, which had a neutral pH, right? A pH of 7. Neither acidic, neither alkaline, just neutral. It could have either a low or a high alkalinity. Imagine now, okay, this glass of water with a pH of 7, we added some acids into it. If it had a low alkalinity, you add those acids in, and they would swim around, and the whole liquid would now be more acidic. And you could actually measure that with the pH meter that you have, because the brew would have become more acidic. The pH will have fallen. It started at 7, now it's at 6. So if you have low alkalinity, then if you bring an acid into a brew, the whole brew becomes more acidic. Okay, now imagine that same glass of water, neutral pH, but this time the difference is it has a high alkalinity. And then we bring in that same amount of acid. But all that acid gets neutralized by the high alkalinity. And so the pH of the liquid stays the same. It stays neutral. It doesn't become acidic. That's a distinction. So a pH meter is not telling us what the alkalinity is, unfortunately.
Yeah, that's actually pretty confusing because what you would think using the word alkalinity, you would think what I thought, alkaline. So alkaline means a high pH. So if I use my pH meter and I see that I have a high pH, I would have very alkaline water. But what you're saying is alkalinity, it's related, but it's not the same thing as alkaline. So alkalinity is that ability to resist a change in the pH.
Exactly.
So yeah, I see why my pH meter is completely useless here.
Exactly. Yes, yes, yes. And now, just to ruin your day further, you also have a TDS meter, right? Now,
why are we friends? You're just ruining.
That's what I do. Okay, so you have a conductivity meter.
Correct.
So a conductivity meter, it's a device, very simple, very cheap, very easy device. You put it in water, right? And it has like 2 forks, and it measures like the amount of electrical current between those 2 forks, right? Those 2 metal forks that you stuck in the water. That is helpful a little bit because it tells us how much stuff conducts electricity in the water. And the thing is, one of the key things that makes limescale, which is the stuff that gunks up our espresso machine boilers, very expensive to fix, is calcium. Calcium conducts electricity in the water. So a conductivity meter does measure how much calcium is in the water. The problem is that there are many other things that conduct electricity too, that this thing is also measuring.
Yeah. No, that totally makes sense. It's like I'm measuring something, but I don't know what I'm measuring, so the measurement isn't really useful anyway.
Yeah. So no, we cannot use a conductivity meter because it just doesn't measure the specific thing we care about, which is calcium. And also, Lucia, while we're here, a lot of coffee people have refractometers, light refractometers that measure the strength of the coffee brew. And that, unfortunately, also does not help us at all but the problem there is the things we care about are not even being measured from light refraction. They don't even register. They're so small, right? The things we care about in water are tiny, tiny things that just don't affect light refraction. So that meter is just not useful.
No, that totally makes sense. Okay, so now I understand why I can't use my pH meter, why I can't use my TDS meter, and why even a refractometer is unhelpful here.
Yes.
So are we going to talk about what is helpful? What should I be using?
All right, finally, what should we be using? Well, the answer is very simple. There are 4 ways you can know the alkalinity and the total hardness of your water. And what I'm going to do now is walk you through them one by one. You ready?
Let's go.
All right. Solution number 1. Your local city water records. So the first way, the easiest way, is to look at your city water records. And if you live in a big city, they should be really easy to find online. The great thing about looking at city water records is that it's free, but there is a downside, which is that the water that's coming out of your kitchen tap might be different from what's stated on the city water record. Because here's the thing, most cities, especially the large ones, they have many different water sources. They could be pulling water from like underground aquifers, dams, rivers, lakes, even maybe a desalination plant. And all those different sources of water have different levels of total hardness and alkalinity. Like, to give you an example, here's a map of Paris with all the different districts and their respective water hardness.
Wow, that's really, yeah. In a small area, we have 3-4 different colors of the level of hardness.
Right? Like Paris has lots of different types of water flowing into it all the time. So all this to say, if you want a more accurate number, you have to measure the water that's coming directly out of your kitchen tap. And this now takes me to solution 2. Measuring your tap water with a dripper kit. So let's see, dripper kits. They're basically like these 2 little bottles, one of which measures total hardness, one of which measures alkalinity. They're really easy to use. You just like drop in little droplets of this into the tap water until the tap water changes color. And then you know, by counting the number of little drops you put in, the water's total hardness and alkalinity. And they're very common, very widely available, because it turns out fish are really sensitive to alkalinity and total hardness. So, Lucia, do you own an aquarium? Do you own fish?
We have a pond in the backyard that we need to do some maintenance on. So we have seen fish in the pond.
Okay.
And we're getting to the point where we need to like up our game of monitoring how the fish are doing.
So in addition to the coffee, you might want to get these dripper kits for the sake of your fish, because maybe they're swimming around in water that they're not very happy with.
Poor little fishies, yes. I think we're going to need to do this anyway.
Yeah, okay, so that's dripper kits. And now, option 3. Sending your water to a testing lab. Another option, easy option, you could send your water for sampling. You'll get extremely accurate results, very detailed. Bit pricey. My research says it might cost you about $50 for like an entry range test. But the fun thing is, if you want to splash the cash, you could go hardcore nerd scientist and do like the really intense test that will give you like the full mineral breakdown using industrial grade chemistry analysis machines like the sort I saw at BWT in Monza, Austria.
With this machine, we now measure the negatively charged ions, and over there we measure the positively charged ions.
That's wild. Like this is like the size of a 1 meter by 1 meter cube. It's huge. So you can measure exactly what's in your water with these lab grade machines, but it's going to cost you like $500.
Yeah, that's pretty pricey.
But I think your fish are worth it.
My fish are definitely worth.
So that's option 3, sending your water to a lab. And now the fourth and final option. Having a conversation with your local roaster. Like just ask your local cafe owner or roaster because they've probably been through this and they have answers.
Actually, I really like this last answer because I think a lot of the times we think we have to do things ourselves. And it's like somebody has maybe already done the research. You can just find that person and ask them.
Amen. Cool. So those are the 4 ways that you can know the alkalinity and total hardness of your water. Congratulations. You've completed part 1 of figuring out good water for coffee.
Yay, I did it.
You finally have some numbers for alkalinity and total hardness. Coming up next, we figure out what to do with those numbers. All right, Lucia, we're now at part 2. We have some measurements, but now we've got to figure out where we go.
I want to go towards good tasting coffee.
And here, I want you to start thinking about this like a map. Because, with a map, to be able to navigate anywhere using a map, you need to know 2 things. You need to know where you want to go, but you also need to know where you are on the map, where you're starting from.
I'm starting with crappy tasting coffee.
Now, we know where we want to go. The Specialty Coffee Association, SCA, on their water quality handbook, they have a diagram, a map of alkalinity and total hardness, and they have a bullseye that we want to hit. But the thing is, when it comes to figuring out where you are on this map of total hardness and alkalinity, all the tools I just mentioned here on measuring water, right? The home test kits, the lab reports, the city's water records, they often use different units from what the Specialty Coffee Association uses in its water quality standards. And this can be incredibly confusing.
Units.
So what I want to do now is walk you through how to align these things so you can get yourself onto the SCA's map, right?
All right, sounds good.
I'm going to show you the most common pitfalls people are going to run into as they try to do this conversion.
Oh no, is there going to be math?
There might be math. But the good news is that for the vast majority of people, there is a very simple answer, which I'm going to tell you, that will help you just sail through this treacherous minefield unscathed. All right, so let's get practical. I'm going to show you how you can take the numbers for total hardness and alkalinity from your local water report, and then how you translate that into the Specialty Coffee Association's map for good water for coffee.
Yeah, let's definitely do an example.
Okay, let's say you live in a city and you want to know your local water. So I'll use an example of myself in Berlin here. I went to the website of my local water supplier and I typed in my postcode and I got some results. Lucia, this is my water. And if our listeners want to see this for themselves, there's a link in the show notes.
Okay, for the listener, this chart is in German, but I feel like even if I spoke German, I would not be able to understand what I'm looking at.
Okay, Lucia, which of these is alkalinity? Which of these is total hardness?
Well, I see pH on there. That's the only thing that is recognizable to me. Oh, wait, maybe fluoride? Could that be?
Nope. No, you're way off. None of these say alkalinity. None of these say total hardness.
Well, and their ranges. You're not even giving me like an actual number. You're giving me a range of numbers.
Right? So it's like, what do we do with this? So this is the first issue you're going to find. In water chemistry, for reasons that will bore you to sleep. There are lots of different words that mean the same thing. For example, in German, total hardness is Gesamtharte, which is the German for total hardness. But you'll find in a lot of like dripper test kits and water results that they use the abbreviation GH from the German word Gesamtharte, GH. Even American and British tests use GH sometimes. So that's a common pitfall right there. GH actually refers to total hardness. And on this Berlin Water Report, look, there's GH.
Okay, and that's a range of 14 to 25.7. That's a big range.
It's a big range. Okay, and now here's the other common pitfall. Alkalinity is on that Berlin Water Record. It's just that they use a different name.
I was just keeping you on your toes, James. You just got to learn more words for the same things.
Yeah. So you don't often see alkalinity. What you will find most often is the term carbonate hardness, which in German is Carbonatharte, spelled with a K. So you will see it abbreviated as KH. And look, in that Berlin water chart, there's KH. So we have alkalinity, 9 to 14, and total hardness, 14 to 26, right?
Sure, I'm still just as confused as ever.
Okay, so we have numbers for total hardness and alkalinity. Great. Now let's get into the mapping, right? We want to put these on our Specialty Coffee Association diagram map. So we know where we are on that chart, and then we know the direction we want to travel to get better water for coffee. Now, there's a link in the show notes to the SCA's water quality chart, which I strongly recommend our listeners look at while we discuss this next section. But if for whatever reason they can't see it, picture this. It's just your typical graph, right? On the left axis, the vertical left axis, that is total hardness. And on the horizontal bottom axis, that is alkalinity. So Lucia, we just got some numbers, right, for total hardness and alkalinity. Here's the SCA's water chart. Where is Berlin's tap water on the chart?
Okay, wow. So if we're looking at this chart, it's on the lower left. So very little alkalinity, very little total hardness. We're almost at zero.
That's what I thought when I first looked at it. But we've made a mistake.
Oh, is it units?
The units are different.
Cool. Thanks, Germany.
Okay, so the SCA uses the units parts per million calcium carbonate equivalent, ppm CaCO3, okay? And what we have up here in my Berlin City Water Report is German degrees of hardness. So we have to translate the German degrees of hardness to parts per million calcium carbonate equivalent.
Okay, I'm going to say no.
I want you to guess, Lucia, how many different measurement systems are there for measuring the alkalinity and the hardness of water?
I mean, well, more than 2 is already annoying. So anything above 2, I'm annoyed. But let's say 10?
You're bang on. There it is.
Yeah?
10. This is page 16 of the SCA's Water Quality Handbook that converts different measurement systems. Link in the show notes for the listeners. There are so many different types. Look at that. You have parts per million of calcium carbonate equivalent. You have the German degrees. You have French degrees, because the French need their own system, of course. You have English degrees.
It can't be left out. Yeah.
Can't be left out.
I'm going to petition for some Guatemalan units of total hardness.
We have moles, which is like the number of these compounds. And then we have the weight of them.
This actually feels, James, I felt like when we started this conversation, I was already kind of lost and feeling a little bit of despair of like what to do. And this has put me deeper into despair. I didn't even know how far away I was from answering my question.
You didn't know how deep hell went.
No. I thought I was on like level 4, but we are in the basement here.
We're in the basement of hell.
Yeah.
But Lucia, don't worry. It looks really confusing. But the thing is, most water readings you're going to find around the world are probably going to be expressed in German degrees of hardness. Okay? And here's the really easy thing. For most people, all they have to do is take that water reading, which will be in German degrees of hardness, right? And then multiply it by 17.85. Okay, that's the number. Don't ask me why. But if you multiply that, then you get the SCA's units, parts per million calcium carbonate equivalent. That's it. That's all you have to do.
Okay, so what you're telling me is that if I was able to do this and get my water readings from alkalinity and total hardness, like when I do my dripper kit, which I will do, or if I was able to send my results to a lab, or if I was able to contact my city for the city water records, they're probably going to be expressed in German degrees of hardness.
Yep.
And so that number still needs to be multiplied by 17.85, and then that's how I can get my result from the SCA chart.
Easy, right? I know it seemed complicated, but really, it's quite easy. So Lucia, my Berlin water report, it had the alkalinity and total hardness numbers in German degrees of hardness.
Yes, and it gave you a big range.
So let's just choose the midpoint of that range. We're going to multiply it by 17.85. And now we have our numbers, Lucia.
Okay, so for alkalinity, we have 214.
Yep.
And then for total hardness, we have 357. So that puts us in a really different place on the graph.
Yes. So tell me, where are we on the graph?
So we are off the charts.
We are off the chart, yes.
Well, first we were in the bottom left-hand corner, and now we are in no man's land. We are not on the chart.
We are all the way in the top right corner, off the chart, way into space on the hardness and alkalinity. So looking at the SCA's water quality chart, where do we want to be? Where is perfect water for coffee?
We want to be, there's this really nice little shape in the middle of the graph that is core zone.
That's the core zone.
It looks like a sail, like a sailboat.
Yes, it does. It looks like a sailboat. Yeah, it's a teal sailboat. That's where we want to be in the water chart. Link in the show notes so you can see it for yourself. So we want to get our waters into that teal zone.
We seem very far from that.
We're very far away. That's right. But Lucia, don't worry, because coming up next, I'm going to finally tell you what you can do to fix your water, to get you closer to the core zone on the SCA water chart.
Okay, finally.
And I feel like what we need here is like celebration, triumphant music. So here's 20 seconds of me playing triumphant music. So Lucia, we are now finally at the solutions. What you can do to treat your water. And I know we've been through a lot, right? We've had to learn about alkalinity, which affects a coffee's acidity. We've had to learn about total hardness, which affects the lime scale buildup in our coffee machines. We've had to figure out how to measure alkalinity and total hardness from our tap water. And then we had to figure out where we were on the SCA's water quality chart and then identify where we wanted to go, which is the core zone, the teal sail like bullseye in the SCA's water quality chart. But now that we've done that, we know which direction we want to filter our water, right? And broadly speaking, there are two directions of travel. If we are too low on alkalinity and total hardness, then we have to add things into the water. Or if we're too high in alkalinity and total hardness, then we have to take stuff out of the water. Now, different people will have waters all over the chart, but generally speaking, most people are either going to have water that's too soft, as in water with not very much stuff dissolved into it, so it's too low in alkalinity and hardness, or water that's way too hard, as in there's too much stuff dissolved into it, and we're going to take stuff out. And so I'm going to present to you the two solutions to treat your water, depending on what kind of water you have. And to be clear, these are what people at home can do, right? These are not professional solutions. I will cover the professional solutions after this.
So what can I do?
Okay, so first up, let's say you discover that your water is too low on alkalinity and total hardness. Your water is way too soft. If your soft water was music, this is what I think it would sound like.
That's beautiful. I want to play that in the evenings. That's like a really beautiful wind down. I want soft water. I want soft water music.
So if your water is too low in total hardness and alkalinity, the answer is super simple. So what you have to do is get some big jugs, fill them up with tap water, and then add in some very specific mineral salts. Things like bicarbonate of soda, Epsom salts.
I can find those. I know I have those available, but how much am I actually going to be adding?
It's a great question, and I won't bore you with all the details, but I have links in the show notes to places you can go to find out exactly what you got to add to get your water perfectly in the SCA's core zone.
Okay, good. I don't think we need any more math on this podcast episode.
No, it's the math-free zone from now on. So that's the soft water taken care of. What about if you have hard water, like I do in Berlin? This, by the way, is hard water music.
Feels very masculine. It feels very fist pump compared to the soft water music.
So let's see, if you have water that is too hard, right? So it's high in total hardness, high in alkalinity, you have 4 different solutions. Buying a filtration kit, using bottled water, using distilled water and adding in minerals, or mix and matching your waters. Solution number 1, filtration. So what I personally recommend, the simplest and most environmentally friendly solution is using a water filter. It can be as low as 10 cents per liter. It's simple because you just change a cartridge every month or year. And of course you use tap water. That's extremely environmentally friendly compared to buying plastic bottles. And so Lucia, for a long time, I used to use these BWT Penguin water filters with a magnesium cartridge.
Yeah, pitcher.
Yeah, I just used one of those and it helped a lot. I'll show you where I got to on the SCA scale. There's a link in the show notes for the listeners. So you can see where I was. I was way up here in the top right, and it moved me quite a bit further down to the bottom left.
Yeah, I mean, you're almost on the chart now.
Almost on the chart. So if you have very hard water, like I do in Berlin, these jug filters, they definitely help. They definitely make my coffee taste a lot better. But in places with really hard water, like here in Berlin, these cartridges get spent really quickly. So, when the cartridge is fresh, I'm not far from the SCA's core zone, but give it a week and I'll be quite far away. But what you could do is what I have recently done, and that is I have got rid of the cartridges because I was getting kind of annoyed having to change it every month. And instead, I put a BWT Best Max Premium filter canister under my sink. And now look where my water is.
Now you're taking another big leap forward.
Massive leap.
But you're still not in the sale.
I'm not in the sale, but I'm actually in the zone for alkalinity. It's just that on total hardness, I'm quite high.
But being high on total hardness is less of an issue for us kind of home brewers because you're doing a pour over, right? You don't have a machine
Exactly.
that you're gunking up.
Exactly. If I had an espresso machine, I would have to descale it on a regular basis still. But as a filter brewer, it's totally fine for me.
Congratulations.
So I'm happy. Can I just, funny anecdote. In preparation for this episode, when I was doing the dripper tests myself, those tests where you can see the alkalinity and the total hardness by dripping in those drops. When I was doing these tests, I would open the kitchen tap and have, regular tap water coming through, and I'd measure the hardness. And I was like, oh, wow, it's super soft. I'm getting great results. And then when I opened the BWT filter tap, I was getting really, really hard water. Oh my God, this is as bad as Berlin gets. I was like, what the hell's going on? And I couldn't figure it out until I realized I'd actually screwed up the installation and I had the pipes in the wrong place. So I was washing my dishes
Classic.
with BWT's beautiful water and drinking really bad coffees.
That's funny.
So if you have hard water, this is my preferred solution. Get a filtration kit. It's cost effective, it's environmentally friendly, and depending on how hard your water is, you might not get smack bang in the middle of the SCA's core zone, but it'll still be a massive, massive improvement. And for me personally, that's good enough. Okay, now, solution number 2 for hard water. Bottled water. So let's see, you live on a farm in Guatemala. You may not have access to the sorts of filters that I have over here in Europe. So what you could do is buy bottled water.
Yeah, that was our first step. Our first step was, okay, what kind of bottled water options did we have nearby? And so Nick went out to our grocery store and bought, 2 or 3 different kinds of commercial waters.
Okay. Now, I really don't recommend buying bottled water just for environmental reasons alone.
Yeah, and it feels bad to have to buy so much plastic constantly.
Yeah. But also, it's pricey. Over time, those costs are going to add up. And the other thing too I want to mention is that be very careful which brand you buy, because most bottled water is actually really bad water for coffee. Here's a chart from the SCA's Water Quality Handbook that shows different brands of bottled water and where they sit on total hardness and alkalinity. Link in the show notes for the listeners.
That looks like it's all over the place.
It's across the map, right?
It just looks like a splatter chart. Like they're just everywhere.
Right? Like, look at this Evian. Like, it's way out of the chart. If you use Evian water, that's bad water for coffee.
Wow, I'm just trying to take this in. Like, this is... Wait, what is that one? Wow, okay. So they're all over the chart. And then I just noticed, I'm like, why is the chart so long? And then there's one that's up in the 800 ppm.
Look at that. 800 total hardness. 800 total hardness.
I mean, that water seems like a punishment. Like, why would you buy that?
So it really matters which brand you buy.
That's wild.
Okay, so that's bottled water. Again, I don't recommend it. Another solution, I don't recommend, but I'm going to say it anyway, is our third solution for hard water. Adding minerals to distilled water. So, you could buy distilled water. That's water which has literally nothing in it. And then you add in salts, minerals. There could even be pre-made sachets, like from the company Third Wave Water. But again, I don't recommend this solution, just purely because of environmental reasons. Of course, there's the plastic waste, but also the CO2 footprint is off the charts. Guess how much CO2 is released to distill a liter of water?
I have no idea. Let's say 10 kilos.
No, you totally overshot. But still, if you use really dirty energy like coal, it's actually 2 kilos. But still, every time you use a bottle of distilled water, 2 kilos of CO2 had to be released to create that.
Oh, no.
So I don't recommend it. But if for whatever reason you really still want to use distilled water, try to find a way to do it which minimizes your carbon footprint. But now, Lucia, I think this now takes me to a solution that might actually work specifically for you and other peeps who live on farms. My fourth and final solution if you have hard water. Mix and matching your waters. So Lucia, you live on a farm and you told me before that the water out of your tap is always changing.
Yes, our water changes all the time because the water source is a spring. And we've noticed a really big change in our quality when we have more rain, less rain, like just, the weather will completely change the quality of the water that's coming into our house.
Oh, so Lucia, here's an idea. Measure your tap water on a regular basis, right? For total hardness and alkalinity. When you notice it's really low, store some of that water aside. When you notice it's really high, store some of that water aside. And then what you could do is just mix those waters together until you're pretty much bang into the SCA's bullseye for water for coffee. So that's a solution for you.
Mixing my rainwaters.
Nick's excited by the idea. Because he's the one who's going to have to do it.
Do it, yeah.
So there we are. Those are my solutions for you as a humble coffee consumer.
Awesome.
And coming up next, let's tackle the professional side. So Lucia, we covered what you can do if you're a home consumer, right? All those options I presented, they were inexpensive and for the most part will get you much, much better water for coffee. But in the professional world, you can't just get close to the SCA's range. You want to be very close to it, ideally in it. This matters for the health of your very expensive espresso machines. And it also really matters if you're a coffee shop owner who has more than one location, because you want to give the exact same flavors across your different locations. But as we know, different waters could lead to different flavors.
Yeah, James, I think that the second point is much more important. And I think that it can have a bigger impact because it's so intangible. You don't really know what you're missing out on. So if you have a customer that goes to get a cup of coffee and then they go back a second time and it's not the same cup of coffee, you've lost a customer, but you don't know that you've lost a customer. And so what is this intangible cost of not giving people that consistency? I think that it's shocking to me how many places don't take this into account because when you're getting your coffee, you're in a vulnerable place. You're either in need of something, whether it's caffeine or comfort. And if you're messing with people at this incredibly vulnerable point in their lives, that is not good business.
Absolutely, absolutely. Lucia, for this topic, I recommend that listeners, they reach out to a company that specializes in water filtration, and they can do all the on-site tests, and they can figure out, what water treatment will specifically work for them and their budgets. We're talking investments here, 1,000, 2,000, 3,000 euros plus. But I do want to mention a solution I saw recently, BWT's Best Barista, that I thought was super cool. And the premise is this. You can install this Best Barista water filter no matter where you are in the world, and it will give you great water for coffee, regardless of what's coming out of your tap, with very little effort. But I'd love to interview you.
Okay.
When I was in Copenhagen, Frank Neuhausen, one of the directors at BWT, explained to me how it works.
So it's fully independent of the local water quality, easy to use, plug and play.
So first of all, it looks like a giant double soda stream. So just 2 cartridges. In the first cartridge, they take everything out.
By reverse osmosis, takes out really everything, a very special membrane that takes out all the minerals.
So now you have almost entirely pure water, nothing in it. And then, step 2,
remineralization process.
They add in a balance of minerals.
It's based on unique mixture of different salts that will be dissolved in a certain controlled process in the cartridge.
And the minerals that are added in bring you basically right bang into the middle of that sail, the SCA's core zone.
With our Best Barista water, we are in the square of SCA.
So you're saying you don't have to go on the journey that you and I went on to fix our waters, which is just a lot of guessing and checking and trying to figure it out ourselves.
Exactly. You buy the unit, ballpark 3,000 euros, but it saves you all the headache. And also, I purposely didn't cover this in this episode, but when it comes to minerals, they have a subtle effect on the flavor of coffee. And this Best Barista unit from BWT also fixes that for us as well.
And with our Best Barista water, we have a full focus on magnesium, what is very well known for a best extraction, and also on silicate, what is known for creating a very stable and great creamer.
Well, the way that I understand it is water for coffee is complex because there's so many minerals that come into play and bring out certain flavors of the coffee. And depending on what coffee you have and what starting water you have, there's so many different options. I could make 15 different water recipes for my coffee. So I think that's where the complexity on complexity starts to build. But what you're telling me is that someone's already figured this out for us. Mm-hmm. Someone said, here is a recipe for water. We think this is the best recipe for water. Try this. That is very appealing to me.
That's what they did. They tested out lots of different water recipes with some partner cafes and roasters.
Took us also almost a year. We tested with our professional partners, baristas, several options.
And they were like, here are different recipes we could put. Tell us if there are any showstoppers, anything that doesn't work.
And luckily there was, let's say, one combination that was the clear favorite of all of us.
And all the feedback they got from the testing said, yeah, there was one recipe everybody liked.
I love that. It's kind of like having your, 85-point coffee that's just the nice crowd pleaser, that coffee that just makes everybody feel like a coffee. Yes. As they're talking. So this is water for coffee.
That's right. That should be their tagline. BWT, water for coffee. So, we've been on a journey now of taking you through water for coffee. How are you feeling?
I'm feeling pretty good. I feel like I have a much better handle on my water. I think that there's not one right answer. I think that we can take it in either direction. You can definitely nerd out way more on water. You could really go off the deep end and get really deep into making your own recipe. Mm-hmm. But I really like knowing that you don't have to. We don't have to go that route to get good tasting coffee. There are some, kind of universal waters. There's some waters that taste much better for most people that are generally good most of the time, and that's good enough for me. I'm one of those people that there's a lot of things I want to nerd out about, but this doesn't happen to be one of them.
Great. If you did want to nerd out more, though, there is a lot to read, content to consume. I got a lot of links in the show notes.
I also want to remind listeners that you did make a full episode, a much nerdier episode on water.
Yes, which actually I've decided to redo and re-release as I have got deeper into the science and better as a storyteller. I saw some places where I'm like, you know what? I think this could be an even better episode. So alongside this episode, I'm re-releasing that original episode. And the story this time, what it's about is how at one point, hundreds of millions of years ago, if you were to drill down into a well and take out some groundwater and made a coffee with that water, that would have been the perfect water for coffee. At one point on planet Earth, we had perfect water for coffee. But then it got ruined. Like what happens with me, I open my tap in Berlin, my water is super hard and my coffee tastes lame. I know who's the culprit. And I tell you the story of the culprits that are literally dead under our feet in their trillions.
All right, well, I kind of was making a promise to myself that this was the end of my water journey, but I think that I'll be willing to listen to that episode.
Amazing.
One more water episode.
One more. And of course, Lucia, if my listeners want to learn more about your podcast, what are they in for?
I really try to go deep into the science of processing with also a lot of stories from my winemaking days. So I was a winemaker for 10 years before I started coming into coffee. So if you have questions about terroir, winemaking processes, I do cover a lot of that.
It's a really great place to go if you want to get deeper into the science of coffee. So peeps, I hope you enjoyed that episode. It's a bit of a different style to what I normally make. Did you like it? Should I make more of this sort of content that, breaks down complicated science stuff in this more kind of conversational way? Let me know. Reach out to me on Instagram at Filter Stories Podcast, link in the show notes. Filter Stories, the science of coffee, and the piano music is all written and played by me. And now let me tell you what's coming up in the rest of the series. The final episodes of the Science of Coffee series will explore a foundational question about our community. Who are we in specialty coffee? What do we stand for? Should we be embracing co-fermentation? Should we be embracing blends? Who gets to decide what quality even is? To answer these questions, I go deep, philosophically, anthropologically, and historically. And I found some answers that gave me a sense of direction. And in case you missed it, here's what else is in the series. The first episodes are about cold brew. I used a Toddy cold brew kit to explain why cold water can give us coffee flavors that we just cannot get with hot water. In the second episode, we go deep into the science of flavor formation and roasting, and I take you with me into the facilities at Probat, and we see the biggest coffee roaster I think has ever been made. This thing is as big as a whale. Then we're in Brazil, where I show you how coffee farmers figure out who to sell their coffee to for how much. One of those ways being through the direct trade platform Al Grano. And then in the episodes before this one, we're in the south of Colombia, in the Andes mountain range, and I show you the journey that coffee takes from the farm down to the port through a commodity supply chain, and why that same coffee going through the specialty supply chain of the Coffee Quest costs quite a bit more. What are we paying for exactly? I really hope you enjoyed this episode, and I'll speak to you next time.